Jai Hind everyone, myself Sandeep Yadav, Assistant Professor, CSC Department at Akgec Engineering College. Today I am going to deliver a lecture on transaction processing, which is a part of DBMS being taught to 5th semester student in CS, IT and allied branches. So this is my topic for today, transaction processing, and here is the outline that we are going to study in this lecture. First is what is transaction, then the properties of the transaction, then transaction state diagram and the schedules. So first of all, we will be discussing what is transaction. Well, most of you have heard the word transaction in financial terms, but here it has different connotation. That is, a transaction is a collection of operation that is used to perform a logical unit of work. So a transaction performs a logical unit of work that contains one or more SQL statement. That is what we are discussing. This. Let us consider an example of transaction. Suppose there is a transaction which transfer 50 from A to B. So let us see how to write this transaction. This is a read command. Read A means we are fetching the value of the data item A from the disk to the buffer. Now we have applied the update operation. After that we write A. So write A, basically what it does is it transfers the updated value of A from buffer to disk and after it is written there, then the value is being changed. Now next is read B. Now read B again involves transferring the value from the disk to the buffer. Thereafter B equal to B plus 50, that is we are changing the value of B. Now the updated value will be the initial value plus 50 and write B. So this whole transaction involves transferring $50 from account A to account B. So this is the transaction. Next is the properties of the transaction. Well, the whole of the property of the transaction can be classified in the ACID, where A stands for atomicity, C stands for consistency, and I stand for isolation, and D stand for durability. Now atomicity means either the transaction executes 0 or 100%. It should not happen that some of the operations of transactions are successful while other are failure. Either all the operations are considered successful or all are failure. There is no transit. Either it should be 0 or it should be 1. Then only it will be preserve the atomicity property. Next is the consistency property. Consistency property means the database must remain in correct state, valid state after the transaction as it was before the transaction. Next property is isolation property, which ensures that when the transactions are executing parallelly to each other, they should not be aware of each other. That is, they should not interfere in the working of each other in concurrent execution. Whereas in the serial execution, we need not to maintain the property of isolation, it is automatically maintained. That means that in serial transactions, only since one transaction is executing at a time, so there is no other transaction to interfere in its working, then the property of isolation is automatically maintained. But in parallel execution, we need to synchronize the things so that the transaction do not interfere in the working of each other. Next is the durability. Now the durability means the thing that should be outstanding. It has a longer life. So once a transaction completes successfully, the change it made must be made permanent into the disk. Now let us discuss the property of atomicity first. This states that a transition must be treated as a single atomic unit. That is, atomic unit here represent it is undivisible. Means it should not be broken into components and some component are working, some are not working. No, it should be atomic one. That is, all the operations should be working. Otherwise, it will be failure. So either the transaction execute 0% or 100%. Let us consider an example. Consider a transaction to transfer 50 rupees from account A to account B. Let us demonstrate it. So this is how you write a transaction. The first we need to read the value of A, then we will update the value of A. That is, updated value of A is A equal to A minus 50. Thereafter we need to write back the value to the disk from the buffer. For that we need the write operation. Afterwards we read the value of that item B, then the updated value is B equal to B plus 50 and write B. This is how we are going to write this transaction. Now consistency means if the transaction if database was in consistent state before the transaction, then it must be in consistent state after the transaction is over. How to check whether the transaction is consistent or not? There is simple thing, that is, if the total of A and B remains the same before the transaction, then after the transaction also it should remain the same. Let us see. Initial value of A is 500 and of B is 500. So total is A plus B is equal to 1000. Now after the transaction the value of A is 450, since it becomes here 450, right, and here it is 550. Now the updated value are 450 and 550. Now summation of this is A plus B is 1000. See, initial sum and the final sum is same. So we can say that the property of consistency is being maintained. Next property is the isolation property. Now changes occurring in a particular transaction will not be visible to another transaction until the transaction has committed. So intermediate results need to be hidden from the other transactions that are executing parallelly. See, they should not be interfering in each other working, so that the transitions run successfully. In our example, once the transition starts from the first step, its results should not be accessed by the other transaction until that particular transaction completes its operation and it is committed. Let us see. See, here the transaction has started and another transaction, another user want to read the value of A. No, it will not be able to do that since it has not, transaction hasn't committed yet. How will it commit? It will commit only after the final write B operation is okay. Okay means it should commit. Only that the value of the values that are being updated by transaction 1 should be visible to other transactions. Otherwise, it will create the problem of inconsistency. Next is the property of durability. After a transaction completes successfully, the changes that it has made must persist even if there are the system failures. So failure may occur in a variety of ways. Either there should be system failure or disk failure, power failure, storage failure. See, sometimes the operating system also decides to kill a particular transaction, or sometimes DBMS also kills a particular transaction due to a logical error or any other error that is possible. So a transaction may fail due to a variety of reasons. So in spite of the failure, the system should continue to work properly and efficiently so that the property of durability is being maintained. See, these are the final values. These values must be permanently stored in the database so that we can maintain the property of consistency. Next is the transaction state. See, transaction is basically like a process that we people studies in operating system. It has a number of states which it must undergo in order to achieve the final committed state. Let us see how many state a transition is having. See, first stage is active state. As soon as the first line of the transition starts, we say the transition is in active state, that is the initial state. Now, next stage is partially committed. When a transition completes its final operations, it is said to be partially committed. After the completion of this line, right B, we will say the transition is partially committed. Next is committed state. The transition enter in this state after the successful completion of the operation. Now, after the operation has been successfully completed, the values are written in the disk. Then, after the values are being written in the disk, we say the transition has completed. We cannot abort or roll back a committed transition. Now, a transition may also enter a failed state from the active state after we discover that its execution is no longer possible normally. Once a transition cannot be completed, any change it done should be undone. Since a transition has failed, so whatever change has been done by that particular transition, we need to undo those changes. See, a transition has failed this at this particular point, so the value that is has updated of A, that we must undo that, so that another transition should read the only the committed value of A, that is the correct value of A. Then abort state is there. After the failed state comes the abort state, the state after the transition has been rolled back and the database has been restored to state prior to the start, that is known as committed state. Aborted states. Now, a transition may also enter from the partially committed state to the failed state. See, even though the last line of the transition has committed, but the value has not been written in the disk. So, various type of failure may occur, which may lead our transition to reach from the partially committed state to the failed state. Now, so that we can say that at the end, the transition can end in only two ways. Either it is a committed state or it is a aborted state. So, these are the two possibilities in which the transition can end its life, either successfully or unsuccessfully, that is the aborted state. So, in a nutshell, we can sum up what are the various states. First is the active state, where the transition stays in this particular state while it is executing. Next is the partially committed state. When a transition executes final operations in this section, we say it is in partially committed state. And the failed state means that we discover that normal execution and no longer proceeds. Once a transition cannot be completed, any change that is done must be undone. Otherwise, the problem of inconsistency can occur. Next is the committed state. The transition entered in this state after the successful completion of the transition. After entering the committed state, we can not undo or roll back any committed transition. And last is the aborted state. The state after the transition has been rolled back and the database has been restored to its state prior to the start of the transition. Next is the schedules. A schedule is the grouping of the transitions into one and executing them in particular order. That is, a schedule is nothing but a chronicle ordering of the instructions, the steps in which the instructions will be executed. So, a schedule is required in the database because whenever the transition execute in parallel, they affect the result of each other. Means if one transaction is updated the value which the other transaction is accessing, then the order of these two transactions will change the result of each other. Hence, a schedule is being created to execute the transactions. This is an example of a simple example of a schedule. This is a serial schedule. In this schedule, there is a transaction T1. It is performing the operations. The value of A is being lessened and the value of B is being added. Here it is added and here it is lessened. And this is commit. Now, after the completion of this instruction, after the completion of transaction T1, that is after the completion of this write B, we start the another transaction T2, which is read A equal to A, temp equal to A in minus 0.1, A equal to A minus temp, write A, read B, B equal to B plus temp and write B. Now, these are the instructions that are being written for this particular transaction T2, right? Now, it is also updating the value of A. Here we subtract something from the value of A and that is being added into B, right? So, this is how the final outcome will be coming. Initial value of A is 1000, then the A value become 950. Initial value of B is also 1000, the value is 1050. Now, this T2 is also doing some operations, then the value of A is temp equal to 950 into 0.1, then A equal to 950 minus temp, that is 95. This value becomes the 95, then this value becomes 855, then the value of B equal to 1050 plus 95, that value is 1145. This is the example was of serial schedule in which no transaction start until the running transaction ends. A serial schedule is a schedule in which one transaction is executed completely before starting the another transactions. See, the transactions here are completed one after another. This type of schedule is called serial schedules since the transactions are being executed serial schedule. Next is the non-serial schedule, interleaved schedule or concurrent schedule. We also say them a concurrent schedules. The schedules that interleave the execution of different transactions. That is, interleaved execution is there, some instructions of some transaction is executing. Now, in between, some instruction of other transactions get executed and so on. Here, the second transaction is started before the first one could complete and the execution switch between the transaction back and the forth. It contains many possible orders in which the system executes between the operations of the transactions. Now, this is the example of a non-serial schedule, that is a concurrent schedule. Here, we are doing the operations on the value of a transaction T1. Now, this is not yet completed, not yet completed. Now, start the another transaction T2. Now, it updates the value of A. Now, this value is being updated, changed. Now, start this particular transaction. After completing of this write B operation, now again this starts. So, this is an interleaved execution. That is, the control is being transferring from one side to other side. Next is the equivalent schedule. If the two schedules produce the same result after the execution, they are said to be equivalent schedule. They yield the same result for some value and different result for another set of values. That is why equivalence is not generally considered a significant property because it does not yield better result. So, these schedules, one is serial schedule, another is concurrent schedule. They both provide the same outcome. These both are equivalent, and this is the reference of the textbook that you can undergo for exploring this topic further. I hope It is clear to all of you?